All right, welcome back to Mr. P Helps with Precal. This is Unit 1, Topic 4, Lesson number 8, the last lesson of this unit. We're going to be solving inequalities again, but ones with rational functions. That's the difference between this video and the last video. So we got to really know our factoring really well. So when you have a leading coefficient, 4 times 3 is 12, and you figure out what factors of 12 also add up to -7. And I would list out all the factors of 12, and the only one that's going to add up to -7 is 3 and 4. -3 and -4. So that's x minus 3 times x minus 4. But you have that leading coefficient of 4, so both of these have to be divided by 4. So that leaves you with x minus 3/4 times x minus 1. Now, you could change this. Technically, this is the same thing as 4x minus 3. That's the exact same thing. If you want to convert this factor into this, no problem. But the reason why I would keep it this way is because that's easily going to tell you the x-intercept. Same step over here. So 5 times 4 is 20. I'm looking for what factors of 20 also add up to -12. It's going to be 1 times 20 or 2 times 10. And it looks like it's going to be -2 and -10. So we have x minus 2 times x minus 10. But we have to divide both of these by 5. So that gives us x minus 2/5, otherwise known as 5x minus 2, same thing, multiplied by x minus 2. And there you go. So don't forget how to do these. So this is factoring out the GCF. They both can be divided by 3, and they both have at least one x. So that makes this x squared. This divided by this is here, and this divided by this is -4. X squared minus 4 can actually be factored again into x plus 2 times x minus 2, because that's differences of squares. Because this is a perfect square, this is also a perfect square, and it's differences because it's got to be, well, anytime it's a binomial, it's got to be differences of squares. There's no sums of squares. Whereas cubes do have sums and differences of cubes. Now keep in mind that this is the same thing as this. 3 to the third power, 3 times 3 times 3 is 27. So if I rewrite this to this, then you understand why it's different. It's sums of cubes. So sums of cubes is written as x plus y multiplied by x squared. Well, back. Come on, I don't have time for this. So x squared minus xy plus y squared. Okay, so that's going to be, so this is x, so that's x is x and 3 is y, so that's x plus 3 times x squared minus 3x, and then times 3 times itself would be 9. As you can see, when you do FOIL in this, you are going to get the exact same thing. X times x squared is x cubed. The x times -3x is -3x squared, and that's going to cancel out with the 3x squared right here. Those cancel out. And then you have the 3 times 9 is 27. So it ends up being the exact same thing. All right, so going back to rational inequalities, I'm only going to do one of these because I do want to meet my time limit. I'm at 3.5 minutes already. So one thing I do want to mention, but I did not show in the other video, is I'm going to skip this question right here because this is just like the video if you just watched prior. But this one's a little bit different because it has an or equal to sign. So when you see an or equal to sign, then that basically means that the 0 is included. So you got to use a bracket to include the 0, because if it's or equal to, then you're saying when it's either greater than the x-axis or on the x-axis, which means the 0 is actually a part of your answer because it could be on the x-axis. So you always got to be careful about what this symbol is right here, whether that's greater than, less than, and whether or not it's or equal to, because then you're including the 0, so you got to use brackets. All right, so I'm going to do the exact same steps I did in the last video. If you did not watch it, if you did not watch it, I would highly suggest that you go back and watch it. First thing I'm going to do here is factor this. This is x plus 2 times, all right, so this would be x minus 7 times x plus 2. That times that is that, and that plus that is less than or equal to 0. Now, I'm going to put them in order. So we've got -2 right here. We've actually got 2 -2s, and then we got +7 right here. Just So if you watched the last video, the next thing I did was identify the intervals which make it that. So like negative infinity to negative 2. All right. Of course, now I'm going to have the problems with the pen. That's what I get for pausing. All right, so try this one last time. Negative infinity to negative 2 and negative 2 to 7, and this will be from 7 to infinity. Now, keep in mind that it's or equal to, so I am going to include the zeros. So technically, this should be a bracket right here, a bracket right here, and a bracket right here. Not a parenthesis. And the reason why is because the zeros are included because it is or equal to. So I'm going to test by putting something in here. So if I put negative 3 into all these factors, negative makes that first one negative. Negative in for x here makes that also negative. And a negative here, negative 3, makes that also negative. Negative times a negative is a positive, times a negative again is a negative. So, ladies and gentlemen, we get an answer that's a negative, and a negative is less than 0. So this is a part of our answer. So we now know our answer is from negative infinity to negative 2. That's a part of our answer, and maybe one of these two is also a part of our answer. So in between these numbers would be like 0. 0 plus 2 is positive, 0 minus 7 is negative, and 0 plus 2 is positive. Positive times a negative is a negative, negative times a positive is still a negative. So it looks like this is also a part of our answer. So or negative 2 to 7. And I'm going to check this. So let me just make sure I didn't make a mistake there. So 0 plus 2 is positive, 0 minus 7 is negative, 0 plus 2, yeah. Okay, and then the last one, so 8. 8 plus 2 would be positive, 8 minus 7 would be positive, 8 plus 2 would also be positive. That's going to give us a positive result. So if we get a positive result, that is not less than 0. That would be more than 0. So this is not a part of our solution. So it's just the first two parts. All right, so now getting to the actual meat of this lesson. So when we have rationals, for rationals, we need to find both the zeros on top and we need to find the vertical asymptotes, because anytime where it crosses the 0 line, and even when you have a graph that has a vertical asymptote and maybe the graph is going like this and like this, it does cross the x-axis. So anytime it crosses the x-axis, then it's going to be a part of the answer because it's flipping from a negative to a positive. So it could be make it a part of the answer. So we got to count both of them. So in this case, we have x plus 8 times x plus 2. 8 times 2 is 16, 8 plus 2 is 10, so this is gone. This is differences of squares. This is x plus 3 times x minus 3. And we're taking into account, we want to know when is the answer either the 0. Zeros do count, so if it lands on these two, it counts. It's a bracket. Not when it's an asymptote, because if it's an asymptote, then it can't be a part of the answer anyway, so you wouldn't include it. Or when it's less. So we're looking for when is it a negative. All right, so this is going to take quite a bit here. So this is negative 8 for this 0. We've got negative 3 for this asymptote. We've got negative 2 for that 0. And we've got positive 3 for that asymptote. So we've got 1, 2, 3, 4, 5 different boundaries here. So we've got 3 to infinity here. Keep in mind that's not included because it's an asymptote. We got negative 2 to 3. Not included here, bracket here, because negative 2 is a 0 and it's or equal to. We have negative 3 to negative 2, bracket, parenthesis. And we have negative 8, bracket, to negative 3, parenthesis. And then bracket, so that's negative infinity to negative 8. Okay, so now we've got our 5 categories. Now it's just a matter of testing, just like we did before. We're not really doing anything different. We're just plugging that number into all 4 of these. Keep in mind that it's going to be division for each one of these. So let me, yeah. Here we go. Okay, let me try that again. So division, 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 division. Okay, so there's 1, 2, 3, 4, 5 different parts. So if I put negative 9 in, negative 9 is going to be a negative, times a negative, over negative 9 would be a negative times a negative. Well, negative times a negative is a positive. A positive divided by this would also be a positive is a positive. All right, so now anything in this category is going to be positive, which is not an answer, because we're looking for when is the answer going to be a negative. All right, 1 down, 4 to go, and I got 5 minutes left. We're plenty of time. All right, so for the next one, I'm going to choose -5. It really doesn't matter what number you choose, anything in between this range. -5 here is a positive. -5 here is a negative. -5 here is a negative. -5 here is a negative. So that's going to be a negative divided by a positive is a negative. That is an answer. So we know this is a part of our solution. All right, I go to the next one. What's in between -2 and -3? -2.5. -2.5 would be positive. -2.5 would be negative. -2.5 would be positive. -2.5 would be negative. Okay, so that's a negative divided by a negative, which is a positive. That's not a part of our solution. In between -2 and 3 would be 0. That's positive, positive over positive, negative. So a positive divided by a negative is a negative. So this is a part of our solution. And then last one to test, 4. So that's positive, 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 positive. A positive divided by a positive is a positive. Therefore, this is not a part of our solution. So it looks like we have 2 intervals of time when it's going to be greater than 0 or equal to 0. And that's when it's from -8 to -3, or, of course, it's not going to let me just press back. All right, let's try that again. Or union of -2 to 3. And there we go. And I'm going to stop it right there because with 3 minutes left, I'm probably not going to have enough time to do one of these U-tries. But honestly, it's the exact same steps. Or actually, maybe I'm going to give it a try. Maybe I'll run out of time. So this is x plus 4 times x minus 4. Okay, this one looks a little bit easier. So we got +5. Okay, so -4 is this boundary. Keep in mind that that is an asymptote. We've got +4 right here and +5 right there. So this one gets included because remember, that's a 0. So it's or equal to. And we're looking for when is the answer going to be a negative. Okay, so -5. -5 minus 5 would be a negative, divided by -5 would be a negative, -5 would be a negative. Okay, a negative divided by a positive is a negative. So it looks like this is part of our answer, -infinity to -4, but not including either. So that's a part of our answer. 0. So 0 minus 5 would be a negative, divided by 0 plus 4 would be a positive times a negative. Okay, a negative divided by a negative is a positive, but that's not what we're looking for. We want to know when is this less than 0. So that's a positive, so this is not a part of our solution. 2 more to go, and I'm going to make it in time. So 6. 6 minus 5 would be positive, divided by 6 plus 4 is positive. 6 minus 4 is also positive. Positive divided by a positive is a positive, which means this is not a part of our solution. Last one, 7 minus 5 is positive. 7 plus 4 is positive, and 7 minus 4 is also positive. I feel like I made a mistake somewhere in here. Oh, did I choose? Oh, between 4 and 4 is 4.5. I feel like I might have done this one wrong. All right, let me just do this all over again, and I was rushing, obviously. So let me use 4.5. 4.5 minus 5 would be negative over 4.5 would be positive. 4.5 would also be positive. Negative divided by positive is a negative. Okay, this is a part of our solution. So from 4 to 5, but also including, because remember 5 is a part of our answer. Now I already did this one, and this one was not a part of our answer. I'm running out of time, so it looks like it's from -infinity to -4, or when 4 to 5, but including 5. All right, thanks again for watching. Have a wonderful day, and I just made it in time. Please look forward to future videos for the next topic and the next unit. Have a great day. Please subscribe if you haven't done so already.